Hola, ¿qué tal? Hola chicos y chicas. Voy a empezar en español. Es que el regular expression es una cosa que todos usamos. He leído un artículo que dice que 1 de cada 3 proyectos informáticos usan regular expression para procesar el texto. Lo usamos todos, pero ¿pensamos del regular expression? ¿Estudiamos regular expression? Pienso que no. Y ahora, porque mi español es terrible, voy a... Soy muy estresado. Voy a cambiar al inglés, pero pienso que podemos discutir en español, charlar después de la charla, pero es más fácil para mí poner la charla en inglés. So, let's switch to English now. What is your first thought when you hear regular expression? What do you think? Regular expression, what is that? Yeah? Complex. Yeah, complex. What could be? It's weird, right? What do you mean by weird? So, you take a regular expression, you craft a very great pattern. By the way, I'm a Ruby developer, so some examples are in Ruby, but bear with me. It's simple. You craft your perfect regular expression, you put it in Ruby or in Python or in PHP, and then you think, I'll just use it to test in grep, and it doesn't work. Why doesn't it work? Because it's weird, right? And that's the reason we don't write regular expressions, right? We just use Google. Because it's too hard. By the way, my weird hobby is to write regular expressions by hand, because I really like it, and it's fun. What is your first thought about regular expressions? Maybe they are surprising, right? You write something, and it works perfectly. It's fast, and it works, and this quite simple regular expression takes 90 milliseconds to match this long string. That's okay, right? But then you make the string a little bit shorter, and this regular expression takes 6 seconds to match. 6 seconds, folks. It's too slow for a HTTP request, not for a tiny part of your application, right? It's just surprising. So we just try until we get something that works, and it's because it's weird and surprising, and it's also cryptic, right? Nobody understands regular expressions. It's just a very ancient language. That's a very simple regular regex, right? You all understand what happens here? Who wants to translate? Yeah, I know, you're shy, you don't want to show off. That's why I think that in many cases, you know, in computer science, we have this concept of something that's read-only, right? We write it and it's read-only, we don't change it. Regular expression is very often write-only. You just write it, you never read it, because it's just too cryptic, right? And it's weird, it's surprising, and it's cryptic, so how is it? What is it? It's magic. Regular expressions is magic, right? Why do you think it's magic? Because, yeah, how does it work? How do we know that these weird characters will match this number? And how does the computer knows it should match this number and not that number? Nobody knows, right? It's pure magic. By the way, I love this magic. And I'm here to talk you a bit about this magic, this kind of magic. I work for Chattermill, and we do a lot of text processing. I just love the previous talk because it was about NLP. I'm a software engineer. I've been software engineer for like, I don't know, 10 or 15 years. So I know the boring part, but we have also the people that do the interesting part, the NLP. But either way, we all do a lot of text processing. We have a lot of regular expressions, and I also did regular expressions in my previous work. And I found they're mesmerizing, fascinating. And I decided I don't want to live with this magic. I want to understand this. And that's how this talk was born. Because I write regex by hand. I know how they work. I discuss their performance. And there were times when I was used to answer on Stack Overflow. And on Stack Overflow, you have like 5 minutes to provide a correct answer because you need to be the first one. So I became very, very fast at crafting regex. Hence, I want to share my knowledge with you. Now, so do you speak regex? Hablas regex? Parlate regex? Mówicie po regeksowemu? By the way, I'm from Poland. Nobody understands Polish, so it's close to regex. When you take why is regex so hard? Because actually, it's not a part of our language. It's a separate language. Can you see this example in Java and in Python? We compile regex, we execute it. It's not a part of our language, it's a separate language. Esto es como mezclar los dos idiomas en una charla. Es terriblemente difícil, right? And that's why it's so hard. And it is a real separate language. And when there is a small library in Ruby that's used for debugging regex. It's called Onigmo. That's how the regex engine is called in Ruby. And you can actually parse a regex, and you can see the abstract syntax tree of the regex just to understand how it is parsed. And you can also compile it, and you can see all the mnemonics of the bytecode that the regex is compiled to, because at least in Ruby, when you compile a regex, when you prepare regex to be used, it is compiled to a bytecode internal to the regex engine. And when you take a look at the C code, there is actually this huge struct, and it's in this huge struct of regex, there is a small pointer to a long array, and this array is just an array of bytes, and it's being interpreted, this bytecode is being interpreted by the regex engine just as any virtual machine interprets the bytecode. That's how it is implemented in many languages. It's a separate language. That's why it is hard to mix it, to mix it. And why do we call it regular? Why is it regular expressions, not weird expression or write-only expression, but regular? Regular sounds like simple, right? And we agreed it's not simple at all. So that's the story of my love-hate relationship with regex. When I was a young programmer at the university, I had an assignment of building a calculator, a symbolic calculator. And I thought it would be a great idea to use regex for this. And then I had two problems. Because this calculator included nested parentheses, nested brackets, and I thought, yeah, it should be possible to parse nested brackets with regex, because regex are just for text processing. That's what I knew about regex. And I was almost there when I realized that I just can't do the recursive regex, and it's impossible. And I switched to another approach because I was late, as many people at the university projects are. And then, probably one semester later, I had this very good, very interesting subject in my curriculum, formal languages and automata. And I learned that actually regex is based on regular languages, and it is formally proved that it's impossible to match nested parentheses using regular expressions, because it is a regular language, and if it's a regular language, it means that if we have a grammar of this language, we can only add stuff on one side of the string, either on the left or on the right. It means that we can't describe balanced parentheses with a regular language. To describe a balanced parenthesis, we need a context-free language. That's the next level of the Chomsky hierarchy, or Chomsky hierarchy, nobody knows. And then we can do the balanced parentheses. But it's a different kind of language. So I thought, yeah, I'll be smarter next time. It's impossible to use regex for matching parentheses. That's like half of the story. Now let's suspend it a bit, and let's move on and discuss how it works inside. So there are three ways of describing a regular language. The first one is a grammar. It's a set of rules. The second one is a regex. the expression that describes it. And the third one is a finite automaton. It's described as a graph, but it's basically a machine that interprets this regex. And there are two ways of interpreting a regex, of checking if a regex matches a string. Let's take a very simple string. The arrow is the pointer, where we are in the text and where we are inside the regex. And the first approach is string directed. It means that we go over the string and we are checking if the regex matches the string. So we start at the beginning, then we go one char ahead in the string, and we are on both sides of the automaton. And next side, we are still good because there is still AA. And then in the next step, we have B on the top and A on the bottom. So we skip the upper part, and we just go on the bottom. So it's a bit like breadth-first search. Through the graph, we go through all the branches at the same time, more or less at the same time. There is also the pattern-directed approach, when we go over the pattern and we check if the string matches. And it's more like depth-first search. We first check the upper branch, and when we realize it doesn't work, it doesn't match, we backtrack, we go back on the string to the branching point, and then we try another branch, and it matches, and it's successful. But you see, it required more steps, right? It was kind of slow. We can say it was kind of slower. And those two approaches are present in computer science. The first one, the text-directed, was implemented by Thomson in 1968. And it was a very simple, there are no simple programs in C, right? But it was a very short C program, 400 lines. It was based on deterministic finite automata. And one thing about this approach is that the performance is predictable. It's lower polynomial, it's very good, and it's simply easy to understand. And there is another approach implemented about 20 years later by Larry Wall, and it's based on the pattern-directed approach, and it's more like depth-first search. And the problem with it is that it's a bit unpredictable if it comes to the performance. So, we have two approaches. The first one is based on sound theory. It has predictable performance, and it's simple. The other one is complex, not based on the theory, and might be very slow. Which one should we choose? Sorry, the first or the second? Who thinks the first one? Who thinks the second one? Yeah, of course, the second one won. Thank you, folks. You all voted wrong. Why is that? The first one is used in grep and in some Unix tools. The second one in Golang, noticeably, and in Rust. The second one is used in everything else. And it was implemented first in Perl, and it has even the name Perl compatible regular expressions. So when you see PRC, it's basically the thing. Why do we use the other approach? Well, it's very practical because it's much further than actual regular languages. You can match something like wiki. You can, for instance, match here the duplicates, wiki, la, I don't know, chow, with this approach, which you can't do with regular languages. You can also implement balanced parentheses with this approach, and you can actually craft a regex that checks balanced parentheses. The guys before the talk told also that with this approach, you can check if a number is divisive by 3. So it's a huge and very complex and very powerful engine, and we use it a lot. So let's try to understand the implications. Is it fast or is it slow? So let's take this one. We match curly braces and then anything that is inside. That's our regex. And we test it on this very simple text, parentheses, text. So what we need is to go over slowly, go over the, if we go with this first approach, we need to first match the parentheses, then go to the end of the text, and then we try to match the closing bracket, and we realized that there is no, so we go back step by step until we find the closing bracket. A lot of steps and a lot of wasted effort, right? But if we make this regex a bit more specific, instead of saying anything that's between brackets, we say anything but the closing brackets actually, because we know that there is a closing bracket at the end, it's much faster. And also in many cases, it's more correct. If you ever want to try regex to match HTML tags, don't ever try to open brackets, anything closing brackets, because then you'll see mostly the whole HTML page. Use the other approach, opening brackets, anything by closing brackets, because that's the way to go. That's like the most popular error in regex, probably. And also, it's not only about correctness, it's also about the performance. What else about the performance? Let's parse this simple regex, and you can see that when we parse A class B or C, there are just two steps. It's a char, and then there is a class. But if this class is shorter, Ruby regular expressions engine optimizes, if this class is single character, it optimizes it, and it only uses direct character matching. That's a bit faster. So we may think that, okay, so maybe instead of short classes, we should do alternative of characters because it's faster. Let's check this out. And if we compile it, we can also see the difference. So we can think that we may compile it and we can use the alternative instead of the character class. But if we use alternative, actually it's getting more complex because the alternative requires backtracking and jumping. So whenever possible, use character classes instead of the alternative because it's faster. Matching alternatives is basically implemented as a bit set, at least in Onigmo. And it's blazingly fast to check it. And with alternatives, you need to go different ways and backtrack, and it's slower. So what to do to make your regex fast is to avoid backtracking at all costs. You should use precise patterns to avoid backtracking. You can also control backtracking by using special quantifiers. There is a thing called a possessive quantifier. It means it's like plus added to the quantifier, and it means whatever you've taken, don't give away, never backtrack. So it changes the semantics, but it may be also faster. It works at least in Ruby and Perl. In other regex engines, it's not possible, it's not implemented. But some regex engines has atomic groups. It means that you can wrap some part of the regex in an atomic group. It means whatever is taken here, never give it away, never backtrack from whatever you've taken from this group. And it also may improve your performance of your regex. Just test it. And other things is use short alternatives, because whenever you have a long alternative, you need to backtrack a lot. And use character classes. By the way, if you have a really, really long alternative, like in thousands of tens of thousands words, don't use regex. There are better alternatives. Check the data structure. Next, but it was still fun at games, right? We are at the university, so we talked some stuff about theory. We showed some nice graphs, and it's still very not practical, right? But maybe regex could kill your app. What's the answer? Of course, the answer is no, right? Because if there is a question mark at the headline, the answer is always no, right? Let's take a very, very bad regex. We need to check any number of A's, but for some reason we nest it. It is an artificial example, of course. The repetition is nested. So if we want to match, and there is B at the end, so if we want to match a string of just A's without the B at the end, regex will try to match the whole string. Then there is no B at the end, and it starts backtracking. And that is when it starts to be interesting, because it backtracks a lot, trying to create this to test all the alternatives of this nested repetition. All the alternatives of this nested repetition means it checks all the subsets, all the substrings, possible substrings of this long string, and it's 2 to the nth. So it's rather slow, and in this case, it's about 112 steps to finish it. So it's pretty slow. And how do we write slow regex? You can, by the way, you can check there is a test app that we'll be all testing in a minute. How to write a slow regex? Nobody does it in purpose, right? Let's say that we have an application and we want to match calculations. And at first we do only simple calculations, just 2 elements, and there is an equal sign at the end. And then we do something more complex, longer ones, but it doesn't work correctly, so we fix it. There is a bug fix, and now what happens? What happens is here we have this this regular expression, and let's try it on something that's correct, and it works well. You can see at the console that it works well. Let me make it bigger. But what happens if we have something that's incorrect? Oh, it's going slower. It's about 1 second. And now my browser hangs. And we can check the performance. And you can see that it's nice. 100% is my Chrome tab. The only thing to do is to kill it. I can't even retry it. This regex is, of course, incorrect, and I'll show you after the talk how to fix it. The problem is that it overlaps. And if we have overlap and repetition, regex engine goes crazy about backtracking. And we should be very specific not to avoid ambiguous overlaps. So it was still an artificial example. Can a regex kill 10% of the internet? Now you're not so sure, right? Of course it can, and it did. It have killed the internet because once it killed Cloudflare, and Cloudflare powered about 10% of the websites on the internet. There was a very long regex, but after this talk you surely understand it. So just point me when the problem lays. Somebody wrote this regex on their web application firewall that checks JavaScript code. So it checks very long files and put it on the internet and put it on their config and set it live. And then Cloudflare was down for 30 minutes. The biggest problem with Cloudflare now is that many of their tools were also down, and it was very hard to revert it. What was the problem? The problem laid here, and to make it even simpler, it was basically a repetition of anything after the repetition of after anything, then equal sign and repetition of anything. So if there was no equal sign, it was backtracking like hell. And I could show you a very simple demo of this one. Is here, and you can see that it's 18,000 steps just to match this very simple string. By the way, I recommend highly regex one-on-one to test regular expressions. It was very bad. What could be worse than killing 10% of the internet, of the websites? What is worse? No, killing just a single website. Killing Stack Overflow is worse. They were trying to match white spaces at the end of the string, probably to remove it. And there was a post that has 100 that has very long string of white spaces and then a dot or something at the end. So it was very, very slow to match it. It wasn't exponential, actually, because the previous examples were exponential. This one was just quadratic, and still it was very slow. It's 200,000 steps to match this string, and it's not even that long. It's just 1,400 characters. And it's terribly slow, and it took Stack Overflow down for half an hour. And do you know what's the worst part of when Stack Overflow is down, how to fix Stack Overflow? Stack Overflow is down, and you can check it, right? So we are probably doomed. We should never use regex again, right? Because it's so dangerous. Well, it's a sharp knife, but fortunately, it got improved over time. It got improved after those famous REDOS cases. REDOS is regular expressions denial of service. It's a term, so it's quite popular, right? There was a case of Discourse. Discourse is a written Ruby forum on the internet. Sam Saffron from Discourse said that one day he had this weird case that everything was, that one host of their client was calculating something. Everything was at 100%. The CPU was at 100%, and they didn't know what it was. He profiled it, he traced it, and he was able to decide it's a regex. And actually, they were processing some French text, and French has this weird typography rules that before question mark, exclamation mark, and semicolon, you have a space. I don't understand it, but they do it. So in HTML, the space should be thin, and they were replacing that if there is a space in front of the question mark, or there is nothing in front of question mark, replace it with thin space to make it look nicely on the HTML. The problem is, yeah, that's the offending part, white space or nothing. Never do this. Never try to match nothing and repeat it, folks. And also, they run it on Apache logs. Why did they run it on Apache logs that has a lot of white spaces and no question marks at the end? Nobody knows. Still, it took 100% of their CPU, and it was a weird case. It was hard. So are we doomed? Probably, right? Probably there are two wrong answers. We can just hope that it works okay. And if it's a user-provided regex, there is another answer in another book. It's just their fault. Yeah, you could finish this talk right now, but actually, there were some programmers that decided that hoping and blaming is not the best game. And in many regex engines, they implemented a timeout. You can set a timeout and say, after 2 seconds, you should timeout and stop this regex. So you have this safety net. If it's very bad, we can time out. There are different flavors of it. It's either time-based or step-based. It's not ideal, but at least it's safe. It is in Ruby. I know it is in .NET. Some kind of step timeout is also in Perl. Okay. And there is also memoization implemented. There was I quote a scientific paper that showed how to implement memoization. That's efficient way of doing so because the naive memoization means that either you have exponential time or exponential memory, and here you have linear growth of memory or polynomial growth of memory, and you don't have the exponential time. You have polynomial timers instead of exponential. So it is a great result. It has been implemented in Ruby 3.2 a couple years back, and it works great there. And it means that you can check if a regex has linear time, and many very bad regexes, that killed innocent apps, are actually linear now in Ruby. So what you should remember after this talk is that whatever you write in, you should switch to Ruby. Similar things were also implemented in and V8 in JavaScript regex engine, but sadly they are not available in Node.js and in Chrome as far as I know. But this killing this app, I killed a simple web app in Chrome. It would be impossible in Firefox. In Firefox, it raises an error, and it doesn't kill the application. And in Safari, I think as well. So it's not that we are not covered. In many cases, we are. And also, if you really want safe regex, use Rust or Go, because they have safe regex engines. And actually, the Go regex engine, RE2, made by people from Google, has bindings to many other languages, to Ruby, to Python. It's written in C++, so you can use it probably wherever. And it is safe. It is, unless it's very, 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 very weird regex, I believe it's safe to put a user-provided regex there, and your application is not killed. So we are not doomed. And actually, there are some optimizations in regex engines, and there are less and less dangerous regular expressions that are out there, and we are safer and safer. Still, there are some incorrect regular expressions, and if you do data science, you probably do it in Python. So please keep in mind that Python regular expression is not only rather basic, but it's always rather dangerous. So be careful. Use it, but be careful. And if you have problems with regular expressions, write me on LinkedIn. I'm very happy to solve it. I'm very happy to talk about regex with random strangers. So, is regular expressions a magic? Yeah, maybe. Maybe it is magic, but we love this kind of magic, right? Because we can go under the hood and we can check how this magic works. And it's wonderful. But you can ask why we should do this. Why have you forced us to spend 1 hour of our time here? The answer is I didn't. There are 3 more interesting talks out there, and you missed them. Why should we bother in understanding magic in computer science? Because we have a lot of this. Databases, full text search, the whole AI, it's magic, right? Why should we bother? There are 2 good reasons that we talked about. The first one is performance. If it's getting slow, you need to understand what's under the hood to fix it, to make it faster. And it's also about security. If you don't understand your tools, somebody could misuse those tools to harm you. And there is also the most important reason for this, and it's pure curiosity. I believe that if you want to be a better engineer, if you want to be a better computer scientist, you need to understand a lot of old stuff. You need to understand what you use. And that's what Feynman said, the Nobel Prize winner. He said that he had this habit of understanding old and boring stuff and rediscovering it, and he was pushing the how new was that the stuff that he understood. First, he understood stuff that was 100 years old and something that was 50 years old, and then he understood something that nobody else understood before him. So if you want to be creative, if you want to be innovative, I believe that you need to start by understanding some kind of old magic just to be able to produce new kind of magic and show it to the world. Because actually, I believe there is no magic in our field. It's just software, and that's something that we built. And now I'm answer a question in any language that you prefer. No funciona.
Questions, preguntas?
Hi, Maciek.
Sí.
I was curious about the Stack Overflow example. Do you think that was intended by the user who submitted the post, that 20,000 blank spaces followed by a dot at the end? Because they knew how Stack Overflow worked and wanted to kill the site, maybe?
I'm pretty sure they didn't know how Stack Overflow works. I believe it wasn't intended. I mean, it wasn't my malicious user. Why on earth he or she decided to write 20,000 white blank space? I don't know. Probably they had good reasons. You just can't imagine what the users will do, right?
Also, well, I depend a lot of LLMs lately to write my regex. So my regex has gotten very bad. And if something goes wrong, I don't really know how to fix it. Is there any way that you share these materials?
Sorry?
Are these materials available? Or
This material will be available. Also, I have a special website with the links to regex materials. And if you really, really want to understand regex, there is a real book, because all those were fakes, of course. There is a book by Friedel, and it's called Regex Internals or Regex Engine. I'll send it surely on my LinkedIn and on my Twitter after the talk. And it's an awesome book. It's 20 years old, but it's still very good. But there is a lot of materials on the internet. Just ping me after the talk. We'll work what's the best for you.
I'll add you on LinkedIn.
Yeah.
Thanks.
Okay. I love the talk, of course, but I'd love to know the real questions right now. How can we fork bomb a college with regex?
Sorry?
How can we fork bomb, just nuke the entire server of a college using regex?
You can use any of the examples of the slow regex. You take Python, and you run enough threads of Python. If you have the direct access to the code execution, then run enough processes of Python just to saturate CPU. But you won't get the access to direct code execution probably. And if you do, the administrators will get you. I mean, it would be possible on my university to run something like this, but for sure the process will be killed promptly, and somebody would call me.
Yeah, in any case, we're not liable for anything that happened here, right?
Yeah, don't take this as an example, as an advice. Just.
I can just do it. So, how does memoization works in the formal implementation?
How does it work internally?
Sorry. How does the memoization works? Like, does it do partial matches of the internals and groups of the regex, or does it do the entire input and provides the already created output?
Okay, that's the question I feared the most. But it is a very good question. So I'll try to draft an answer. So when the automaton is built, it identifies states that are similar. It rules out the states that have only one input because they are probably not used very much. And then it tries to, it adds a function that memoizes the results of what happens if you go into the state and if you have the output from the state. And that's it. So it's on the automaton level. It's not on the pattern level. And if you want to check the details, read this paper. It's quite dense, but it's well described. And if you want to check how it's actually implemented, check how I can send you a link to Ruby implementation. It's just some thousands of, probably 1,000 or two of C code with macros, so you'll surely understand it.
Yeah. Okay, thanks.
First of all, thank you. I like the speed, and I have a question because I always worry about maintainability, but I find regex are fun, and I love them. And I want to ask you when you know you shouldn't use a regex in your code. because I'm not always aware of the situation. I not detect when to stop. You know, where's the line?
Okay, that was a bad joke that I was about to say. You shouldn't use regex if you have a simpler way. So if you have a regular string method that does the same, don't use regex. So if you want to trim white spaces in the end, there is a specialized way. If you want to replace a part of the string, and it's a well-known, I don't know, you want to replace Java for PHP in the whole text, you don't need regex, it's just the direct string matching. Use regex whenever you need to do something like very complex pattern matching, and you can't easily program it. Don't use it, as I said, don't use it if you have like long alternatives, because it is very slow, because you need to backtrack a lot. Use tree. There are blog posts on the internet like how we use this smart algorithm to be much faster than regex. So I can send you after the talk. When not to use it, yeah, don't use it to check if a number is divisible by 3. So for complex text processing, text matching, not for the simple tasks. And for maintainability, it is possible to write multi-line regex with comments. So if you really want to, you can do this, comment every line and explain what you do in those parts. And of course, have good tests, not only for the happy path, but for the bad path. And for the most important for performance point of view is almost matching. As I showed before, only one character is missing because that's the slowest.
Okay, thank you.
Hi. As ChatGPT is the new Stack Overflow, have you tried to execute this backtracking problems in ChatGPT or any other Gen AI if they try to compile or execute the regex?
I mean, have I tried to kill ChatGPT with a regex?
Yeah.
Wow, that's a nice idea.
Thank you. It's my present for you.
Yeah, I need to check it. I need to check it now. I haven't. I mean, I know that a lot of people use ChatGPT for regexing. It's even more risky than using Stack Overflow for regexing. But yeah, it works 90% of the time.
Ok, so sorry, no tenemos más tiempo para más preguntas. Muchas gracias, Maciek. Y si tenéis alguna pregunta, seguro que podéis hablar con él. Podéis pillar el cronómetro.